In this very lesson, we shall be looking at the real number system. Real number system. And I believe that at this very stage, each and every one of us knows what a number is. Numbers plays a very significant role in our daily activities. In the area of business, such as buying and selling, numbers plays a very vital role in that very aspect. Let's take it that you want to buy an item at the mall, let's say a shirt. And we know that at the mall, prices of items are fixed to the items you want to buy. Let's say the price of the item is 100 cedis, 100 Ghana cedis. When you go to the mall, you see that the price of the item is attached or fixed to the item you want to purchase. And the price of the item will be written in numbers, 100 Ghana cedis, 100. And 100 is written in numbers. So at this very point, numbers have been used. When you go to the area of the health, or when you go to the health sector or the hospital, they also make use of numbers for taking the vitals of their patients, such as their weight, their heartbeat, and their temperature. So when you go to the hospital, they will let you to stand on a scale, and then your weight will be recorded as, let's say, 45 kg. That is your weight. So 45, which is your weight, is written in numbers. At that very point, numbers have been used. When you come to the educational sector, we make use of numbers a lot. In subjects such as mathematics, we make use of numbers all the time. Let's take it that you have 1 plus 1. This gives us 2. 1 and 2 are numbers. At that very point, numbers has also been used. When we were at the basic level, down there, we learned about some types of numbers. We learned about the even numbers, the odd numbers, and then prime numbers. And I believe that you can still explain and give examples of these very numbers. We are going to continue with this, and we shall be looking at what we call natural numbers. Natural numbers. So we have 1, natural numbers. Now, natural numbers are positive counting numbers that start from 1 up to infinity. They are positive counting numbers that start from where? 1 up to infinity. And natural numbers are mostly denoted with this very symbol. So when you say this should tell you that we are talking about natural numbers. So they start from where? They start from 1, 2, 3, 4, up to infinity. That is what natural numbers. So we can talk of thousands, 100,000. We can talk about million, billion, trillion, quadrillion, quintillion, sextillion, and so on. They are all natural numbers because they are all positive counting numbers. The next set of numbers that we can also talk of is what we call whole numbers. Now, when we talk about whole numbers, we are referring to positive counting numbers that start from 0 up to infinity. With whole numbers, it starts from where? 0 up to infinity. So we can say that 0 plus natural numbers gives us what? Whole numbers. And whole numbers are indicated or denoted with this very symbol. So when you see something of this nature, this should tell you that we are talking about what? Whole numbers. Whole numbers include 0. So plus natural numbers gives us what? Whole numbers. So you can say our whole numbers start from 0, 1, 2, 3, up to infinity. And I believe you can give examples of whole numbers and natural numbers. Let's continue. We can also talk of what we call integers, another set of numbers, integers. Now, integers are also denoted with this very symbol, z, and then something of this nature. So when you say this will tell you that we are talking about integers. Now, what are integers? When we talk about integers, we are talking about infinity positive and negative whole numbers. They are positive infinity and negative infinity whole numbers. So we can say that with integers, they start from infinity negative numbers and then infinity positive numbers. So when you see a set that contains negative numbers and positive numbers and then a whole number, you can say that that set is a set of integers. I guess you are following, and I believe you can give example of integers. Now the next set of numbers that we can also talk of is what we call rational numbers. Now when we talk about rational numbers, we are referring to numbers that can be expressed as a fraction of two numbers, or it can be expressed as a fraction of, let's say, a over b or p over q, where q is not equal to 0. So when you have any number that can be expressed in this very form, then you can say that that number is a rational number. A rational number takes the form of fractions, percentages, and terminating decimals. So when you talk about fractions, we can talk of 1 over 2, 3 over 5, 2 over 7, and so on. Now all these numbers here are rational numbers because they have been expressed as a fraction of two numbers, 1 over 2. So you can see that the 1 represents p and then the 2 represents what? Q. So fractions are examples of rational numbers. Another type of rational numbers is percentages, and I believe we can give examples of a number written in a percentage form. We can talk of what? 10%. Good. So we have 10%. Now 10% means what? 10 out of 100, which is written as 10 over 100. So we can see that 10% has been expressed as a fraction of two numbers, 10 and then the 100. 10 represents P, 100 represents Q. So we have expressed 10% as a fraction of two numbers. Another example of a number written in a percentage form is, let's say, 50%. And we all know that 50% means 50 over 100. So we have 50%, which means 50 over 100. So we have been able to express 50% as a fraction of two numbers. So we can talk of a lot, so and so on. We can also talk of terminating decimals. Terminating decimals. They are decimals that ends or terminate. Examples of such decimals, we can talk of, let's say, 0.4. 0.4 is a terminating decimal. It ends at where? 4. And we can write or express terminating decimals as a fraction of two numbers. 0.4 can be written in a fraction form, and that is what? 4 over 10, which is the same as what? 2 over 5. So we can say that 0.4 is a rational number. You can also talk of terminating decimals such as 0.25. So 0.25 is also a rational number because we can express it as a fraction of two numbers, and that is what? 25 over 100 or 1 over 4. Another type of numbers that are rational numbers is what we call counting numbers. Counting numbers. All the counting numbers are what? Rational numbers, because they can be expressed as a fraction with a denominator of 1. You know that any number is over 1. So 2 is over 1, 3 is also over 1, 4 is also over 1. But just that we don't write the 1. So you can say that all the counting numbers are also rational numbers. I believe you are following. Good. Now the next set of numbers that we shall also be looking at is called irrational numbers. Irrational numbers. Now irrational numbers. If the number is not rational, then it is what? Irrational. So what are irrational numbers? Based on the concept that you have learned from rational numbers, what are irrational numbers? Irrational numbers are numbers that cannot, the emphasis is on cannot be expressed as a fraction of two numbers. So with irrational numbers, we cannot express as a fraction of what? P over Q, where Q is not equal to 0. An example of such numbers that cannot be expressed as a fraction of two numbers are non-terminating and non-recurring decimals. So we have non-terminating and non-recurring decimals are irrational numbers. Can you give me an example of a non-terminating or a non-recurring number? We can talk of what? Pi. 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 I believe that each and every one of us have heard of what? Pi. Because down there or at the basic level, we learned about pi. We were able to use pi to find the area of a circle, because we know that the area of a circle is given as what? Pi r squared. Pi. This is pi. Now what is the actual value of pi? Now when you punch pi on your calculator, so this is the calculator. So let's take it that you want to find the actual value of pi. So let's press shift, and then down there you will see 10 x 10 power x. So you press that very part. So you see that pi is on the screen of your calculator. To find the actual value of pi, we are going to press SD. Let's press equal sign before the SD. So we have that. And the actual value of pi is given us 3.1. Now the value on the calculator, or the figure that the calculator has given you, is an approximated value. Your calculator can take up to 10 digits, 10-digit numbers. So when you count the numbers in the calculator, you are going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. that doesn't mean that this is the actual value of pi. It continues till thy kingdom come. So this is an approximated value. Good. So when we look at pi, we are seeing that this number does not terminate because it continues. So we call it a non-terminating, a tunta. It does not end, it continues. So we call it what? Non-terminating decimal. Now with the non-recurring decimals too, you realize that the figures, the decimal parts, okay, the numbers there are different. It changes. It changes from 1 to 4, 4 to 1, 1 to 5, 5 to 9, 9 to 2, 2 to 6, 5, 4, and then it changes in that very order. So we say that this number is a non-recurring decimal. So pi is a classical example of an irrational number. Another example of irrational number that we can talk of is root of prime numbers. So let's take root of 2. Root of 2 will also give us a non-terminating and non-recurring decimal. So let's point it on a calculator and then see. So we have root of 2, that gives us 1.2 and so on. As I said, the value of these very figures has been approximated because the calculator can take up to 10 digits. Some of the numbers are here, but the calculator can't take it. Good. So you can see the root of 2, the figures here are not recurring, neither are they terminating. So we call root of 2 non-terminating and non-recurring decimals. And non-terminating and non-recurring decimals are examples of irrational numbers. I guess you can give examples of irrational numbers. Good. The very next one that we shall be looking at is real numbers. Real numbers. So we have VI. So real numbers, and it is mostly denoted with this very symbol. So real numbers are combination of rational numbers and irrational numbers. They are combination of what? Rational numbers and irrational numbers. So you can give any example of rational and irrational numbers. They all fall under real numbers. I believe you can give examples of such numbers. There are lots. You can talk of pi, root of 2, 25, 0, 2, 3, decimals. They are all what? Real numbers. Let's look at what we call recurring decimals. Recurring decimals. So we have recurring decimals. Recurring decimals are decimals that repeat or recur. An example is, let's say, 0.33333 and so on. You can see that the number 3 recur. In other words, the number 3 repeats. So you can see that the decimal part, which is these real parts, the number 3 repeats in that very order. So you can say that 0.33333 is a recurring decimal. Now instead of us writing 0.33333 till thy kingdom come, we can shorten it by writing it as 0.3 dots. 0.3 dots. This will tell you that this number is recurring or repeating. Another example of a recurring decimal or repeating decimal is 2.525252 and so on. You can see that with the decimal part we have 52, 52, 52, 52, 52, 52 in that order. So you can see that this number is a recurring decimal. And the parts that recur or repeat is what? 52. So in writing it in a short form, we can write it as 2.52 dot dot. Now, with the dot, we can also write it as 2.52 dash. This means the same thing. This will tell you that this number is recurring. What I want you to do is that write down 5 examples of recurring decimals in your notes. I'll be with you in a minute. So I guess you were able to give examples of such numbers. Now let's use the Venn diagram to illustrate the real number system. So this is an illustration of the real numbers using the Venn diagram. Now you can see from the Venn diagram that natural numbers, whole numbers, and integers are subsets of rational numbers. So you can say that natural numbers, whole numbers, and integers are all subsets of what? Rational numbers. We can also observe from the Venn diagram that natural numbers are subsets of whole numbers. We can also observe from the same diagram that natural numbers and whole numbers are subsets of integers. We can also observe that natural numbers, whole numbers, integers, rational numbers, and irrational numbers are subsets of the real numbers. So all these are subsets of the real numbers. I believe you are following. So we can say that irrational numbers are subsets of real numbers. Rational numbers are also subsets of real numbers. I guess you are following. This brings us to the end of today's lesson. If you are new on this video channel, can you like, share, and then most importantly, subscribe to this video channel for more interesting episodes to come. See you tomorrow. Bye 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 bye.